Okay, so this is question 5 from exercise 11A in the first year mechanics textbook. So we've got velocity as a function of time, and we're asked to find the initial velocity. So that's not a problem. So initial velocity is going to be the velocity when t is 0. So the function is that v equals 3t squared minus 10t plus 8. So when t is 0, the velocity would just be 8. Okay. Then we need to find the values of t when the when the body is instantaneously at rest. So it's going to be at rest when its velocity is 0. So there's the velocity 0. So that's just solving a quadratic. So you can put that straight into your calculator. I think this probably factorizes. So if I do minus 4 and 2, I think that works. So I get t is 4/3 or t is 2, and they're both in seconds. Actually, that doesn't look like it says 25. Let's write that a little bit neater. Okay, and then, so I'm getting two solutions, but if I read the question again, it says values of t, so that's good. That makes me think I've done it correctly. The values of t when the velocity is 5 meters a second, so this is really quite a similar question, just really checking that you've got this. So when does the velocity equal 5? Okay, so let's make it's a quadratic, so we need to make it equal to 0. And again, I think this factorizes, but you can put it into your calculator. So if I do 3 and 1, yep, so t is 1/3 of a second, or t is 3 seconds, and again, it wanted values of t, so that's looking pretty good. And then the greatest speed of the body, okay, so that's going to be when velocity is its greatest, as it says in the question. So I'll do, you don't definitely need this, but let's just do a quick sketch, because from part B, we've got the two intercepts. So there's an intercept of 4/3 and 2 seconds. And from part A, we know, well, we get a top or y intercept pretty easily anyway. So this is a graph of velocity against time. I know that that's 8. I know that that's 4/3 and that's 2. And yeah, it's actually quite important that they've asked for the greatest speed between 0 and 2. Because if they'd asked for the greatest velocity, it would have been, sorry, go back to the graph, it would have been 8. But if they're asking for the greatest speed, that's going to include a negative velocity, which is going to be the magnitude. So we're only looking between 0 and 2, so we're only looking at this part of the graph. So the greatest speed is either going to be 8 or it's going to be the magnitude of the velocity here. So it really just depends on what the vertex is. So let's get the vertex. So you can either do that by differentiation or by completing the square, and you can put it straight into your calculator to help you complete the square. So v was, what was v? So v was 3t squared minus 10t plus 8. So if I'm going to complete the square, I'm going to take 3 out as a common factor. This just going to leave the 8 on its own, that doesn't need to be factorised. And I'm going to halve. Yep. I'm going to halve the 10 over 3. So I could have just put 5/3, but I've written that now. And I'm going to minus that squared. And I'm going to plus the 8. So then I've got the velocity is 3 times t minus 5 over 3 squared minus 100 over 36 simplifies to 25 over 9. I've got to be really careful with where my brackets are. So if I multiply 3 by 3, I get 3 minus that. That's going to be 25 over 3 plus 8. So that gives me, so still have a lot of effort here just by putting this into the calculator, to be fair, but we're committed now. So minus a third. So assuming I haven't done anything wrong there, the vertex is at, the vertex is at 5/3. I should just put this into the calculator, right, is at 5/3 minus a third. So after all that, it turns out no. So the velocity, the lowest velocity, so the velocity here is minus 1/3 meters per second. So the speed is 1/3 meters per second. So no, the greatest velocity, so that's not greater than this velocity we had here. So going back to that, our actual final answer to D after all that is just 8 meters per second. Just double check those answers. Yeah, that's all good.